In this video, I'd like to look at an intricate example of how we work with parallelograms. Remember that a parallelogram has four important characteristics that you need to learn. In a parallelogram, both pairs of opposite sides are equal. Both pairs of opposite sides are parallel. Both pairs of opposite angles are equal. And the diagonals bisect each other. Also, just like all quadrilaterals, the interior angles add up to 360 degrees. Let's look at our example. In the sketch below, QPYR and PTSX are parallelograms. A, prove that XY is parallel to RS. And B, if QT is equal to 9 units, determine the length of 1, XY, and 2, RS. Let's start with part A. Prove that XY is parallel to RS. Now, diagrams like this can seem very complicated and extremely confusing. This is a perfect example of why it is always a good idea to draw on your graph, as it gives you a better idea of what you're working with. The question tells us that QPYR is a parallelogram, so let's make it blue. It also tells us that PTSX is a parallelogram, so let's make this parallelogram purple. Part A asks us to prove that XY, let's make it red, is parallel to RS, so let's make this line red as well. We are considering two lines that are different sizes, so we will probably need to use the midpoint theorem. To use this theorem, we need to determine the triangle we're going to consider. X sits on line PR, so let's make this line green. Y sits on PS, so let's make this side green. Now we have triangle PRS. According to the midpoint theorem, in order to prove that XY is parallel to RS, we first need to prove that X is the midpoint of PR and Y is the midpoint of PS. So let's make our whole diagram black again. The question gives us information to help us find our answers. The question tells us that QPYR is a parallelogram. So once again, let's make this parallelogram blue. Now let's look at PR. Once again, let's make it green. PR is a diagonal of parallelogram QPYR. So we can say in parallelogram QPYR, we know that PX is equal to XR because the diagonals of a parallelogram bisect each other. On our diagram, let's put a small blue line on PX and a small blue line on XR to show that they are equal in length. Now let's make our diagram black again. The question also tells us that PTSX is a parallelogram. So once again, let's make this parallelogram purple. PS is a diagonal in the parallelogram. So let's make it green. Now we can say in parallelogram PTSX, PY is equal to YS, because once again, the diagonals of a parallelogram bisect. On our diagram, let's put two blue lines on PY and two small blue lines on YS to show that these lines are equal in length. Now let's make some space and make our diagram black again. For this question, we need to prove that XY is parallel to RS. So let's make these lines red again. We know that X sits on PR, so let's make PR green again. And we know that Y sits on PS, so let's make PS green as well. In order to use the midpoint theorem, we need to prove that X is the midpoint of PR and Y is the midpoint of PS. We have just proven that px is equal to xr, which means that x is the midpoint of pr. We've also just proven that py is equal to ys, so y is the midpoint of ps. And we can use the midpoint theorem and consider triangle PRS. So let's say in triangle PRS, we know that px is equal to xr. We have already proven this. We don't need to prove it again. So as our reason, we simply say proven above. We also know that py is equal to ys. And again, as our reason, we say proven above. According to the midpoint theorem, if a line is drawn between the midpoints of two sides of a triangle, it will be parallel to the third side. We know that x is the midpoint of PR, and we know that y is the midpoint of PS. So we have now proven that xy is parallel to RS. And as our reason, we can say the midpoint theorem. Now let's make our diagram black again, and we can put a small blue arrow on xy and a small blue arrow on RS to show that these lines are parallel. Now we can move on to part B. If QT is equal to 9 units, determine the length of XY. Now QT is a very long line. It goes from Q to X, X to Y, and Y to T. The whole thing is 9 units long, and we need to find the length of this middle section over here. Parts of QT lie in both of our parallelograms. So let's break QT down into sections. We know that QPYR is a parallelogram. So let's tidy up our diagram and make the parallelogram blue. QY is a diagonal in this parallelogram. So let's make it red. Now we can say in parallelogram QPYR, we know that QX is equal to XY because the diagonals of a parallelogram bisect. Now we know that QX is the same length as XY. So let's make our diagram black again. And we can put 3 small lines on QX and 3 small lines on XY to show that they are equal in length. Now we still need to consider YT. YT lies in parallelogram PTSX. So let's make this parallelogram purple. YT is part of the diagonal XT. So let's make the diagonal red. Now we can say in parallelogram PTSX, we know that XY is equal to YT because the diagonals of a parallelogram bisect. XY is the same length as YT. So let's make our diagram black again. And we can put 3 small blue lines on YT because it's the same length as XY. Now we can make some space. Let's consider the whole line of QT. We know that QT is 9 units long because this has been given to us in the question. We also know that QX plus XY plus the third section, YT, is all equal to QT. But we've also just proven that QX is the same length as XY, which is the same length as YT. This means that QT can be broken up into 3 equal parts. So if QT is 9 units long, 9 divided by 3 is 3. So XY must be 3 units long. Let's put a 3 on our diagram for the length of xy. And finally, we can move on to part B. Determine the length of RS. RS sits down here. Let's make it red. It is the base of triangle PRS. So let's make our whole triangle red. Now, according to the midpoint theorem, we know that if a line joins the midpoints of two sides of a triangle, it is parallel and half the length of the third side. We just found that x and y are the midpoints of PR and PS respectively, and we found that xy is 3 units long. We've already proven this, so as our reason, we say proven above. We also know that xy runs parallel to RS, which means that x is half the length of RS. So if xy is 3 units long, then RS must be double that length. So we can say RS is equal to 6 units according to the midpoint theorem. And we have now completed this question.